Welcome back to my page, Medicnator. We'll be treating physics today. Physics. And we'll be discussing SI units and dimension. SI units and dimensions. So this is what we'll be treating today. So SI units means international system of units. It is the international system of units. And we have two types of SI units. We have the fundamental units and the derived SI unit. So the fundamental SI unit, which is the number one, is the basic unit used to measure a quantity. Is a basic unit used to measure a quantity. So examples of it, there are 7 of it. There are just 7. We have temperature measured in Kelvin. We have time measured in seconds. We have mass measured in kilogram. We have luminous intensity measured in candela. It's written with CD. We have length measured in meter. Measured in meter. So how many are written? 1, 2, 3, 4, 5. We have electric current measured in ampere. We have amount of substance measured in mole. So 1, 2, 3, 4, 5, 6, 7. These are the 7 fundamental SI units we have in physics. As far as it is from SS1 to SS3, these are the fundamental SI units we have in physics. So they are just the basic units used to measure quantities. Now we will go to the derived SI unit. Derived SI unit is obtained when there is combination of 2 or more fundamental units. Example, let's take velocity. You know, velocity is distance over time. Is distance over time. So distance is measured in meter, time is measured in seconds. That is m over s. M over s will give us meter per second. You write it like this, or you write it this way, meter per second. Sorry, they are the same thing. You should not confuse you. So that's telling you that velocity is a derived quantity, it's not a fundamental quantity. Now, same thing with acceleration. Acceleration is change in velocity over time. That is meter per second over seconds. Divide them, it will give you meter per second square, telling you that acceleration is a derived quantity. Let's check for force. Force equals to ma. Remember that mass is measured in kg. That is F equals to kg multiplied by meter per second square. It will give you kilogram meter per second square. Now it will be saying, they say that the SI unit of force is Newton, but why am I writing this? That's the only thing that is to confuse us. You know, 1 Newton equals to 1 kilogram meter per second. 1 Newton equals to 1 kilogram meter per second. So that this Newton is just a special name they gave to the SI unit of force. It's still the same thing. Understood? So this is all about SI units. We'll move to dimensions now. Dimension tells us the fundamental physical quantities that make up a physical quantity. And the three important fundamental quantities that we use to dimensionalize is mass, we represent it as m; time, we represent it as t; and length, we represent it as l. So you cannot use any other quantity apart from the three. Now let's dimensionalize force. Force equals to mass acceleration. Now F will be equals to m multiplied by acceleration. Acceleration is a LT per 2. I'll still tell you how we got acceleration. So m multiplied by acceleration, which is LT per 2, it will give you m. So this is the dimension of force. So you'll be asking, how do you get LT per 2? We got it because acceleration is equals to change in velocity over time. The change in velocity is LT per 1. That is LT per 1 over time. So it's just like indices. When you are dividing, you subtract the powers. When you are multiplying, you will add the powers. So since there's no power here, I assume that there's an invisible one on top of this place. So this minus 1 minus 1, because you're subtracting, will give you minus 2. That is where we got LT per 2 as acceleration. Do you understand now? Now that's how we also use it to get force. Now let's go to work. Work is force times distance. I'm just trying to connect all of them together. Force times distance. Now we already know the dimension of force, which is MLT per 2 multiplied by L, because length is measured in meter, distance is measured in meter, and they told us that it's only mass, time and length that we can use to dimensionalize any quantity. So since distance is measured in meter and length is measured in meter, we are going to use length, which is L. Now the rule, I'm going to use indices to connect it here, which said if you are multiplying base, you are going to keep the base and then subtract the powers. So now L plus L will give me L2. So this is how I'm going to get my work, which is ML2 per 2. This is my work. This is the dimension of work. And the last one for today will be let's go with momentum. P equals mv. I know you guys can do this one, but let me just finish it up. Momentum will be equals to mass times LT per 1. Minus times 70 power 1 will give you what? MLT power 1. So I'm going to give you this one to treat in the comment section or try it on your own. Find the dimension of power. Power. We all know that power is work over time. So find the dimension of power. If you can drop it in the comment section, good. If you can do it on your own, good. Thank you for watching.